So unit 2, that is ideals and homomorphisms. So coming to the first definition, that is right ideal. A non-empty subset capital U of a ring capital R is said to be right ideal of capital R if it satisfies the following conditions. First one. So for A comma B belongs to capital U implies A minus B should also belongs to capital U. That is the first condition we have to prove. And in the second condition, for A belongs to U, comma, small r belongs to capital R implies we have to prove that AR should also belongs to capital U. So if these two conditions are satisfied by a non-empty set capital U of a ring capital R, then we say that that non-empty set U is a right ideal of capital R. So we are saying that U is a right ideal of capital R because in the second condition, we are having small r on the right side of small a. So since the element small r is on the right side of the element small a, so that we call this ideal as a right ideal of capital R. Similarly, if we want to define left ideal, so there also we are having two conditions, and in the second condition we are having small r on the left side of the element small a. So this is the difference between right ideal and left ideal. If the element from the ring capital R is on the right side of the element small a, we say that that ideal is right ideal. Similarly, if the element from the ring capital R is on the left side of the element small a, we say that that ideal is a left ideal. So immediately I am defining left ideal. So once again, a non-empty subset capital U of a ring capital R is said to be left ideal of capital R if it satisfies the following conditions. So coming to the first condition, once again, for A comma B belongs to U implies we have to prove A minus B belongs to U. And in the second condition, for A belongs to U and R belongs to capital R, we have to prove that RA belongs to capital U. So this is the difference between right ideal and left ideal. So both conditions are same, but in the second condition we are having small r on the right side of the element small a, whereas in left ideal we are having small r on the left side of the element small a. So we call this as a left ideal and we call this as a right ideal. So these are the definitions of left and right ideals of a ring capital R. So if you want to define an ideal, definition of an ideal, once again a non-empty subset capital U of a ring capital R is said to be an ideal if it satisfies the following conditions. conditions. So coming to the first condition, that is for a comma b belongs to u. Once again, we have to prove that a minus b should also belongs to u. And coming to the second condition, for a belongs to u and small r belongs to capital R, we have to prove that both RA comma AR should belongs to capital U. It means, so both the elements AR and RA, if both these elements belongs to capital U, we say that non-empty subset capital U is an ideal. If only AR belongs to capital U, we say that ideal is an right ideal. Similarly, if only RA belongs to capital U, we say that ideal is an left ideal. So please keep it in mind that if AR belongs to U, if AR, so since R is on the right side of the element small a, so that we call that ideal is a right ideal. And RA, here the element from the ring capital R is on the left side of the element small a, so that we call this ideal as a left ideal. And if these two conditions are satisfied by a non-empty set together, it means RA and AR, whenever these two elements belongs to capital U, we say that non-empty subset capital U is an ideal of capital R. Okay, so this is about ideal, right ideal and left ideal. So here we are having some note points. So coming to note 1. Note 1. If R is a ring, then U is equal to single term set 0 is an ideal of capital R, and it is called null ideal zero ideal. Okay, this is note 1. So if R is a ring, then clearly single term set 0 is an ideal of capital R. Okay, so we call that ideal as a null ideal or zero ideal. So coming to the next point, that is note 2. If R is a ring, then capital R is itself an ideal. So what is the second point means? Every ring is itself is an ideal. That is the second point. So from note 1 and note 2, I am concluding that every ring is having two ideals. Every ring is having two ideals. One is zero ideal and the second one is itself. Every ring is itself is an ideal, and every ring is also having zero as an ideal. So it means every ring is having two ideals. So one is zero ideal and the second one is itself. These are the two note points, and these two ideals, every ring is having two ideals, we are saying that, and we say that these two ideals are called improper ideals. So every ring is having two ideals. Those are single term set 0 and itself, and we call those two ideals as an improper ideals. Okay, that is the note 3. So note 3, if capital R is a ring, then single term set 0 and capital R are called improper ideals. So we call those ideals single term set 0 and full set capital R as an improper ideals. And if any other ideals exist for the ring capital R, we call those ideals as proper ideals. Okay, so other ideals are called proper ideals. Other ideals are called proper ideals. Okay, so every ring is having two ideals. One is single term set 0 and the other one is full set capital R. And we call these two ideals as an improper ideals. And if any other ideals exist other than these two, we call those ideals as proper ideals. Thank you.